Okay, according to my watch, it is now 8:30, so let's go ahead and get started. Take out a sheet of paper if you haven't done so already. Go ahead and follow along with me. This should be fun. Today, we're talking about parent functions. What is a parent function? What are the 10 basic types of parent functions? And what do they look like? All of those questions are going to be answered today. All right. So what is a parent function? We're going to start there. Let's do a definition real quick. So whenever I do a definition in this class, I'm going to write DEF, dot, dot, and that just stands for definition. So I want to define what a parent function is. A parent function is actually the simplest type of a family of functions. So a parent function. Let's define that. A parent function is the simplest type of function in a family of functions. In a family of functions. Now, I know you don't really know yet what a family of a function is, but you can think about it this way. If you have a family of functions and they're all the same basic type, then the parent function is going to be the generator of that family of functions. It's basically the simplest type of function in a whole family of functions. So if I was given the family, let's say f of x equals x squared plus 3, and I was given g of x equals negative x squared, let's say h of x is a different function. Let's say that's x plus 1, the quantity squared. Well, this is a family of functions, right? This is a family of functions, and the simplest type of function that kind of corresponds with this whole family would be the parent function p of x. And that p of x would be equal to the simplest type, which is just x squared. So what I'm doing is I'm taking the parent function, which in this case is p of x equals x squared, and I'm just kind of editing it each time. So if I add 3 to it, I get f of x. If I put a minus out in front, I get g of x, negative x squared. And let's say if I add 1 to the x and then I square the whole quantity, that's how I get h of x. So I'm taking the simplest function, which is p of x, and I'm editing it. I'm editing it a couple ways, and then I get to f, g, and h. So a parent function is just the simplest type of function in a family of functions. So that's what a parent function is. So there are 10 types of parent functions that I want to talk about today. So let me put a star by this. And whenever I put a star by something, this is just a note that you need to know. I want to say that there are 10 types of parent functions. 10 types of parent functions. Or 10 categorizations, something like that. There are 10 types of parent functions, and we're going to talk about all 10 today. Okay? So I'll leave that up there for a little bit, and then we'll move on to the next slide. And we'll talk about the very first parent function that you should know. Now, I will say a lot of these functions you've already seen before. You probably saw them in pre-algebra or algebra 1. You've already seen them and you know what they look like. You probably even graphed some before, or your math teacher made you. Whichever way you came to it, you'll know a couple of these. But then again, there are some in this list that you have not seen before, and we'll spend a little extra time on those. Okay, so let's go on to the next slide. Okay, let's talk about the constant function. The constant function. That's going to be number 1. All right, so the constant function is, you can write a function in a couple different ways, but the constant function is going to be f of x equals c, where c is a real number. C is a real number. So what this is it's just going to be a number. That's all it is. So let's say we had the function f of x equals, let's say c can be any real number. So let's just say 3. F of x equals 3. Well, what would this look like? Well, if you were to graph this on a calculator, or if you were to open up Desmos, you would see that this is a line at 3. So I'm going to put down 2 points on my graph. I'm going to put a point here, and I'm going to draw a line through them as best as I can. There we go. Perfect. And now I'm going to put arrows at the very ends. What this is it's a horizontal line that goes through y equals 3. It's going to go through y equals 3. And this makes sense, right? Because if you were to go up 3, 1, 2, 3, you would hit the first point of the graph, which is 0, 3. And then what you would do is you would draw a horizontal line through that point. And that would be f of x equals 3. So all this is it's a horizontal line, at y equals c, where c is any real number, like I was saying. So this is just a horizontal line. That's all it is. This is the most basic type of parent function you'll ever see. Another way you can think about it is it's a line with a slope of 0. So a slope of 0, you know that if you have a line with a slope of 0, it's just going to be a horizontal line, right? There's not really a slope to it. You're not going uphill, you're not going downhill, you're staying on level ground. And that's what 0 slope means. It's just a horizontal line, basically. So that's the first type of parent function that you'll see. And the number could be a positive number, like I did in that example, f of x equals 3, but it could also be a negative number, right? It could be f of x equals -5, or it could be f of x equals 0. As long as it's any real number on the other side, that's going to be called a constant function, okay? So now let's talk about the next function, the linear function. The linear function, L-I-N-E-A-R, function. I hope I spelled that right. Linear function. Okay, so what does this look like and how do you write it? Well, we're always going to use f of x for every single parent function. So you're always going to see f of x equals something. This is just going to be f of x equals x. Okay, and we've all graphed this one before, right? This is just going to be a straight line that goes through the origin. What's the origin, you may ask? Well, it's the point 0, 0, right? So it's going to go through this point right here. But since it has a slope of 1, it's also going to go through the point 1, 1 right here. And it's also going to go through the point -1, -1. So now I got 3 points. I'm going to draw a line through them as best as I can, I hope. Okay, how do I do this? Yeah, there we go. All right, perfect. This is f of x equals x. A linear function is always going to be a line. I guess that's the first thing I want to say. Linear. The word linear means line. So you're always going to have a line. Not necessarily a horizontal line or a vertical line. It is going to have some slope to it. So for this one, the slope is positive 1. Your slope is positive 1. But you could edit this function, right? You could actually write this function as f of x equals mx plus b. Right? You learned in Algebra 1 that you can write a line as mx plus b, where m is the slope and b is the y-intercept. Remember that? Maybe, maybe not. Well, you can edit this function so that the line can have any slope it wants, as long as it's not 0 or undefined. So the line could have whatever slope it wants, and it can pass the y-axis at wherever it wants. Here, it's passing the y-axis at 0. But you get what I'm saying, right? You can take this linear function, this parent function, the simplest function, and you can edit it. You can edit it so you can get any line. So that's going to be the linear function. It's just going to be a line. Not a horizontal line necessarily, or a vertical line. It's just going to be a line with some slope to it, right? Another way you can write this out is ax plus by equals c. And all those capital letters A, B, and C are just numbers. This is actually called standard form, if you don't recall. Standard form. While this is called slope-intercept form. Slope-intercept form. So that's the linear function. Okay, so let's take that to the next level. We talked about linear function where f of x equals x, and x is just a variable, right? Well, we can square it, right? So what's the next exponent up? That would be f of x equals x squared. So let's talk about that. F of x equals x squared. This is the third parent function that I want to talk about. Now, this is going to be called the quadratic function. Quadratic function. You've probably seen that word before, but you didn't know what it means. Well, let me tell you. Quadratic just means the highest exponent is 2. Quadratic, the word quadratic in quotation marks. Quadratic means highest exponent is 2. Highest exponent is 2. Not 3, not 4, not 1, but 2. Okay? So what does this function look like when you graph it? Well, if you were to graph this, and I'm going to pop on over to Desmos to show you how it's done. This is Desmos. Let me resize my window. There we go. Okay. So I'm here in Desmos, and I can graph whatever I want on the left side of the screen. So on the left side where you see my cursor, I'm going to type in f of x equals x squared. And what do I get? I get this U-shaped graph right here. It's got a point at 0, 0, and it's also got 2 other points, right? It's got a point at 2, 4, and -2, +4. Okay, so we're going to start with those 2 points, and then we're going to move on to 2 more points, which would be 3, 9, -3, 9. Because those points also show up. And I should probably label 0, 0 as well. There we go. That's the origin. Okay. So heading on back to my screen down here, let's finish graphing this. So I'm going to have a point at 0, 0. I'm going to have a point at 2, 4, 2, 4, and -2, +4. And then I'm going to have a point at 1, 1, and -1, 1. The other points are off the screen, but basically you try to connect the dots as best as you can and as smoothly as you can. Put arrows on the ends, and you're done. That's the quadratic function. And that's all there is to it. Okay, so what happens if you go one more exponent up? You won't be at x squared anymore, you'll be at x cubed. So that's the next function that I want to talk about. So let's go ahead and look at that. All right, this function is going to be called the cubic function. Did I get it? Yep. The cubic function. Okay, so this function is going to be f of x equals x cubed. So how does this look? Well, if I was to go back to Desmos, and let me get rid of all this stuff. Let's say I was to graph f of x equals x cubed. I would get this graph right here. It kind of looks like a flipped upside down S. So what points does it have? It has a point at 0, 0. It has a point at 2, 8. You can't see it up there, but it also has a point at 1, 1. It has a point at 1, 1. It also has a point at -1, -1 down here. So let's graph those. Okay, so back on my graph, we're going to have a point at, let me change my color, 0, 0, 1, 1, -1, -1, 2, 8, it's all the way up there, -2, -8, it's all the way down there. So let's connect the dots. And then I draw arrows at the ends. Good. So that's the cubic function. That's how you graph that. Cubic means the highest exponent is 3. The highest exponent is 3. And that's all I'll say about that. Now, you can keep on going up by exponent, right? So we started off with x, we went to x squared, we went to x cubed. You could go x to the 4th power, you could go x to the 5th power. Really, any positive integer you can do, right? So if you have f of x equals x to the n power, if n is even, your function is going to look like this. It's basically just going to be a U shape. But if n is an odd number, you're always going to get this shape, no matter what. So if n was 6, or if n was 8, or if n was 10, well, those are even numbers, so they would all look like this. But if n was 9, or 7, or 5, since n is an odd number, it would look more like this. So no matter what, every single function has a shape. and you can classify them by their graph, right? Okay, let's move on to number 5. The fifth function that I want to talk about is what? The absolute value function. Absolute value function. I feel like this one is underrated in the sense that it's not really talked about that much. But the absolute value function is important, and it will show up on the SOL test. So how do you write this? It's going to be f of x equals the absolute value of x. The absolute value of x. So this is going to be a V-shaped graph, and I'll show you why in a second. This is going to be a V-shaped graph. Okay, so let's set up a simple XY chart. We'll start off with the negative numbers, and then we'll move on to 0, and then we'll talk about the positive numbers, and we'll go from there. So if I was to let x be a negative number, we know that the absolute value of a negative number would just be its positive counterpart. That's kind of what absolute value means. So if I was to take the absolute value of -2, I would get +2. So I'm going to put a +2 right there. If I take the absolute value of -1, I'm going to get +1. So I'm going to put a 1 right there. The absolute value of 0 is 0. That's kind of trivial, right? And positive numbers stay positive. So the absolute value of 1 would be 1. The absolute value of 2 would be 2. So I'm going to fill this in. So now we can take all 5 of these points and we can put them on our graph, right? Let's try that. So I've got 0, 0. That's going to go right here. I've got -1, 1. -2, 2. I've also got +1, +1. That would go right here. And +2, +2. And you can keep on doing this pattern, right? The pattern's going to keep on going like that. And on this side like that. And then you connect all the dots with straight lines as best as you can. That's as good as you're going to get. So that's the absolute value function. It's not a U shape like the quadratic function was. It's a V shape. That's totally different. In fact, it's going to have a really sharp point right here. It's going to have a really sharp point. We call this like a sharp point, or I know in calculus class, they call this a corner. It's a very sharp point where the two-sided derivatives don't match. Unlike in f of x equals x squared, where you have the general U shape, this is a V shape that has a corner to it. So that's one way that it's totally different than x squared. It's a V shape, not a U shape. So that's the absolute value function. Okay. So now let's talk about some more functions that you might know, but you probably never graphed before. Let's talk about the square root function. The square root function. Everybody knows what a square root is, right? Yes? I hope so. What does the square root look like? Well, it's going to kind of look like this. It kind of looks like a long division house, you know, but it's got an X on the inside. This is the square root function. Now, if you were to graph this, here's what it would look like. First of all, the graph is unlike anything you've seen before. Let me explain what I mean by that. The graph is going to only start on the right side of the graph. So it's going to start at 0, 0. it's going to go to 1, 1, and then 4, 2, and then 9, 3, which is off the page. But you can kind of link up. That's terrible. Hold on. There we go. That's a little bit better. The graph only shows up on the right side of the screen. There's nothing over here on this side. It starts at 0, 0, and it just goes to the right. It never goes to the left. So that's what the square root function looks like. Now, you could also have the cube root function, and that's what we're going to talk about next, the cube root function. The cube root function. This one is totally different. So let's talk about it. Okay, so what's the formula for this one? It's f of x equals cube root of x. Cube root. So there's a difference between a square root and a cube root. Cube root function is going to look like this. It's going to have a point at 0, 0. It's going to point at 1, 1, and negative 1, negative 1. And then what's the next point for the graph? You know, you can take the cube root of 8 and get 2. You can take the cube root of 8 and get 2. So the next point is going to be 8, 2, which is off the graph, but it's probably going to be sort of over here. And then you could have the cube root of negative 8, right? Cube root of negative 8 is negative 2. So you could have the point negative 8, negative 2. That would look kind of like this, I guess. And then you just kind of connect the dots, right? It's going to kind of look like that. Let me put the arrows where you can see them. There we go. So that's the cube root. Unlike the last function we did, the square root function, this one is going to actually span the whole graph, the left side and the right side. So that's a key difference between the square root and the cube root. Okay, so we got 3 more to go. I know you're excited. These last 3 functions are the most difficult to talk about because some of them you've probably never even seen before, but let's talk about them. Okay, the next one we're going to talk about is called the reciprocal function. The reciprocal function. What does that look like? Well, what does a reciprocal mean? It's kind of like you're taking a fraction and you're flipping it, right? The reciprocal function is going to be f of x equals 1 divided by x, or 1 over x, where x cannot equal 0. Because if x really was 0, you would be dividing by 0. You would have 1 divided by 0, which is undefined. So x can't be 0, but it can be any other number, right? As long as it's real. Here's what the reciprocal function looks like. And before I put it on this screen, I want to put it on Desmos. So let's take a look at that. Okay, f of x equals 1 divided by x. And here I get this purple graph. Notice that there are 2 parts to this graph. There's a part of the graph that lies in the first quadrant up here. And there's a part of the graph that lies in the third quadrant down here, right? So this is what the reciprocal function is going to look like. Notice there's no point on the y-axis. There is no point on the y-axis. or the x-axis for that matter. And that's because the y-axis and the x-axis are asymptotes. Asymptotes, right? So now we're getting into really complicated functions where you have what are called vertical and horizontal asymptotes. And 1 over x has them both. Okay? So what are some points that we can graph for this function? You're going to have a point at 1, 1. You're also going to have a point at -1, -1 for starters. You're going to have a point at 2, 1/2. I'll put 0.5. And you're going to have a point at, let's say, -2, -1/2, -0.5, right? And you can get other points as well by just plugging in different numbers for x. So that's what the reciprocal function looks like. It kind of looks like two U-shapes, right? It looks like two different U-shapes. They're just in different quadrants. And we can say these two U-shapes are directly opposite from one another. So let's go back to our screen. This is going to be two U-shapes. Two U-shapes. We call this a hyperbola. Maybe you've heard of that before. We call this a hyperbola. And it's got a graph that looks like this. Sort of. As best as I can draw. That's as good as you're going to get. So it's two U-shapes, right? And we can say confidently that this has a vertical asymptote. A vertical asymptote at x equals 0, also known as the y-axis. So it has a vertical asymptote, but it also has a horizontal asymptote, right? It also has a horizontal asymptote. It has a horizontal asymptote at y equals 0, also known as the x-axis. So it has both vertical and horizontal asymptotes. All right. Let's talk about the last two. And whenever you talk about these two, you got to do them together, right? So let's talk about the exponential function. The exponential function. We'll put that over here. And then let's talk about the last function over here, the logarithmic function. These two are kind of like the yin and the yang. And what I'm going to do is I'm going to copy this. Perfect. Okay. So these are two different types of functions, but what you'll notice about these is they are opposites of each other or inverses of each other. So let's just talk about it. What is the formula for the exponential function? The formula is f of x equals a to the x power, where a cannot equal 0. But a is definitely going to be a real number. This function is going to look like this. It's going to have a point at 0, 1, 0, 1, and it's going to kind of look like this. It has a horizontal asymptote. It has a horizontal asymptote. It gets really close to the x-axis, but it actually never touches it. it has a horizontal asymptote at y equals 0. Let's just say that. It has a horizontal asymptote at y equals 0, also known as the x-axis. This function is not like the quadratic function. So the quadratic function was f of x equals x squared. But if you wanted to make the number the base instead, it would look like this. F of x equals 2 to the x power. And that's the difference between the exponential and any other function. In any other function, you would have x raised to a power, x raised to a certain number, the exponent. Whereas in the exponential function, the number is the base. The number is the base. And the exponent is the variable. The exponent is the variable. So that's the difference between this function and any other function that you might see. And yes, it does have a horizontal asymptote, but not a vertical asymptote. That's for the logarithmic function, which we'll talk about now. The logarithmic function is written as f of x equals log base b of x. And make sure you write the b small and kind of below the log. Okay. And I'm pretty sure b has to be greater than 0 for this to work. Okay. B is called the base. It can be any number that's greater than 0. This function has a vertical asymptote, which you'll see when I graph it. It has a vertical asymptote at x equals 0, also known as the y-axis. That means that this function gets really, really close to the y-axis, but it never actually crosses it. Let me show you what that looks like. So your function is going to have a point at 1, 0. So it's always going to have this point right here. Not like the other one where it was at 0, 1, but 1, 0 over here. And you're never going to cross the y-axis, so you're going to get really close to it, but never cross it. And then the function is just going to go like that. That's the logarithmic function. Okay? So can you see how these two functions are kind of opposites of each other? If you can, that's good. If you can't, let me show you why. Let's look at Desmos real quick. Okay, so here I'm at Desmos. I'm going to get rid of all this trash, and I'm going to replace it with an exponential function. Let's say f of x equals 2 to the x power. 2 to the x power. This is the function that we were talking about earlier, where 2 is the base and x is the exponent. It's basically going to look like this. It never crosses the x-axis down here, right? It'll get close to it, but it'll never actually cross the x-axis. Okay, that is the exponential function. So now let's graph the logarithmic function right under it. So this is going to be g of x equals log, and we're going to let the base be 2. So actually, I'm going to back up a little bit. I'm going to bring up my keyboard. Let me see if I can find the log function. I hope this works. Yep. The base is going to be 2. On the inside of the parentheses, you're going to have the variable x. Okay. So this is what it looks like. I'm going to change this to green because why not? Perfect. Okay. So what you'll notice about this function is it does have a point at 1, 0, just like this one has a point at 0, 1. But for this graph, it never crosses the y-axis, right? It's got that vertical asymptote. It'll get close to it, but it'll never cross it. And now we can zoom in, and you can kind of see why these two functions are opposites of each other. If you can't, let's graph another function with it. Let's graph the linear function. H of x equals x. Now do you see it? Do you see the symmetry? It's kind of beautiful because if you look at it, it's kind of like the purple function is being reflected over the red line. So if I was to take that purple function, this curve right here, and I was to reflect it over this red line, I would get this green curve, the logarithmic counterpart. So exponential functions and logarithmic functions are opposites of each other, or we like to say in math that they're inverses of each other. And that's the point I'm trying to make. Okay, going back to the screen though, these are two functions that are opposites of each other. One has horizontal asymptotes. Do not get that confused with a logarithmic function, which has vertical asymptotes. So I saved the last three functions because they all have asymptotes. The logarithmic, the exponential, and going back a slide, the reciprocal. Okay. And those are the 10 parent functions. I went on a little bit longer than I wanted to, but I think it was good. So let's go on to the next slide and let's talk about what's going to be due on Sunday.